Okay, so this is 5.3, proving triangles are similar. So this is similar to congruency, but it's going to be a little bit different. Okay, so let's start off with some theorems to prove triangles are similar. We start off with AAA squiggle, and that means angle, angle, angle similarity. If the three angles of one triangle are congruent to the three angles of another triangle, then the triangles are similar. It's just like what you think. So if I have two triangles here, and I tell you which ones are congruent, then these two triangles have to be similar. We label these the same way as we label other triangles, and you could say that triangle ABC is similar to triangle DEF. So we use this symbol here to signify similarity. We also have angle, angle, squiggle, so angle, angle, similarity. If two angles in a triangle are congruent to the two angles in another, then they're similar. A lot of times we would rather use AA similarity instead of AAA similarity because we know that in two triangles, all right, if we have this, the third angle has to be congruent to one another. So as long as we've proven that these two angles are congruent and these two angles are congruent, then this triangle and this triangle have to be similar. Okay, now we have some more things. We remember we had CPCTC, corresponding parts of congruent triangles are congruent. But now we're looking at some other ones. We have CSSTP and CASTC. These stand for corresponding sides of similar triangles are proportional, and corresponding angles of similar triangles are congruent. These are our two important things for similar triangles. So these might be helpful for when we start to prove things, okay? In order for us to use them, we have to prove that the triangles are similar first, and then you can apply CSSTP or CASTC. So here's something that we talked about a little bit. So the lengths of the corresponding altitudes of similar triangles have the same ratio as the lengths of any pair of corresponding sides. So for example, I can say, okay, 2 to 4 are the ratio of the altitudes, right? Because I have 2 to 4. And we want to check, is that congruent to 3 over 6? Well, I think that a half is equal to a half. All right, so that shows that the lengths of the corresponding altitudes, these two here, have the same ratio as any ratio of the given proportional sides. Okay, here are two more theorems that we use to prove that triangles are similar. So we have angle, angle, angle similarity and angle, angle similarity so far. We also have side, angle, side similarity and side, side, side similarity. So these are just like what you think. If two sides of a triangle are proportional to two sides of another triangle, and the included angle of one triangle is congruent to the included angle in the other triangle, then they're similar. So if I have these two diagrams right here, I can say, okay, I know that angle B is congruent to angle E, and so let's check the proportions of the other two sides. So 5 over 10, is that equal to 6 over 12? Well, yeah, a half is equal to a half. So these two triangles are similar. So you would write that as ABC is similar to triangle DEF, and if this was a proof, you would write side angle side similarity. So you need that squiggle at the end. Side, side, side is just the same. If three sides of one triangle are proportional to the three sides of another triangle, then they are similar, not proportional. Then they are similar. Okay, so this would be the same thing as checking. Is 2, so this side corresponds to this side, 2 over 4. Is that equal to, let's see, 4 over 8. Is that equal to 6 over 12? Yes. A half is equal to a half, which is equal to a half. So yes, triangle ABC is similar to triangle, well, let's see, I did this, ABC, so this one is EFD. Okay, and we would write it by side, 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 similarity. Okay, this is to go off what we talked about a little bit in class yesterday, but it's the backwards way. So yesterday in class, we talked about if two lines are parallel, then we cut these segments into proportional pieces. But this time we're going backwards. So if a line segment divides two sides of a triangle proportionally, so if I divide this proportionally and this proportionally by DE, then DE is going to have to be parallel to the third side of the triangle, which is AC. So I want to check that. 2 over 8, does that equal 3 over 12? Yeah, 1/4 equals 1/4. So that tells me that AC is parallel to DE. Okay, so now let's look here. I'm given a diagram, I'm given some givens, and I want to prove something. So first I know that MN is perpendicular to NP, and QR is perpendicular to RP. And I want to prove that MNP is similar to QRP. So first of all, I want to write in here what I know. I know that this makes a right angle and this makes a right angle. So what I want to do to start off is to write my givens down. So MN is perpendicular to NP and QR is perpendicular to RP. And that's because it's given to us. Okay, so this tells me that the measure of angle MNP is equal to 90 degrees. And the measure of angle QRP is also equal to 90 degrees. And why do I know that? Well, I know that because of the definition of perpendicular lines. Okay, so now I know, okay, if I have two things equaling to 90, then that means that these two things have to be equal. So the measure, so this kicks us down here, of angle MNP, just rewrite that, that's a little messy. So I know I have the measure of angle MNP equals the measure of angle QRP. And why is that? Well, that's just straight substitution. All right, so now I look here and I notice, okay, if I'm looking at these two triangles, MNP and QRP, what do they both have in common? They both have P in common. So angle P is congruent to angle P. And why is that? Well, that's because of the reflexive property. The reflexive property. Okay, because angle P is being used in both of the triangles. So once I go from here, I forgot that I need to make sure that I say angle MNP is congruent to angle QRP. And that's by the definition of congruent lines. I mean angles, excuse me. Because if two angles are congruent, then they have the same measure. And so last but not least, I can say that triangle MNP is similar to triangle QRP, which is what I needed to prove. And how can I prove that? Well, let's see. This gives me an angle. That's this angle here and this angle here. And angle P gives me another angle. That's this angle. So I have angle N and angle P in the big triangle, angle R and angle P in the second triangle. So now I can say, oops, not side. I can say by angle similarity that those two things are similar.